When converting a 3-wire range circuit to a 4-wire configuration, it's crucial to adhere to the National Electrical Code, specifically sections 250.140 and 250.142. These sections address the requirements for grounding and bonding of ranges and cooking appliances. Section 250.140 covers 3-wire branch circuits for ranges with a separately grounded neutral conductor. Subparagraph A, isolated grounding conductor, specifies that the grounding conductor must be either an insulated or bare copper conductor. The installation of this conductor must follow the guidelines outlined in section 250.122b. This section details the sizing and installation requirements for equipment grounding conductors. Subparagraph B, range receptacles, states that the grounding conductor must terminate at a grounding terminal within the range receptacle itself. Subparagraph C, a junction box, addresses the use of a grounding terminal on a range receptacle. In this case, an equipment grounding conductor is required to be installed from the grounding terminal on the range receptacle to a grounding terminal in an outlet box. It is important to note that this outlet box cannot be a device box intended specifically for the range, cooktop, or oven. This equipment grounding conductor must be sized appropriately, matching the size requirements of the branch circuit conductors serving the range. Section 250.142 addresses grounding and bonding requirements for ranges and cooking appliances in general. Subparagraph A, grounding and bonding jumper, mandates the use of a grounding and bonding jumper. This jumper must be sized in accordance with section 250.120b and should be installed between the frame of the range and the equipment grounding conductor of the branch circuit. The connection should be made at the point where the branch circuit conductors terminate at the appliance. Section 250.120b provides the specific requirements for sizing the grounding and bonding jumper based on the size of the ungrounded conductors. Subparagraph B, equipment grounding conductor connections, specifies how the equipment grounding conductor of the branch circuit should be connected. For ranges, wall ovens, countertop ovens, or cooktops, the equipment grounding conductor must be connected to the grounding terminal of the appliance. Similarly, for range hoods, the equipment grounding conductor should be connected to the grounding terminal of the range hood. Subparagraph C, connecting grounding conductors to range receivers, addresses situations where the manufacturer's instructions specify the connection of grounding conductors to the grounding terminal of the range receptacle. If the manufacturer requires it, then grounding conductors must be connected accordingly. When undertaking this type of conversion, there are several additional considerations to keep in mind. Firstly, ensure that the new range is designed and compatible with a 4-wire connection. Not all ranges are designed for this type of connection, so it's crucial to verify compatibility before proceeding. Secondly, the electrical service to the apartment complex must have a separate grounding conductor. This is essential for providing a proper grounding path for the 4-wire configuration. Without a separate grounding conductor, the safety and effectiveness of the grounding system may be compromised. Thirdly, and perhaps most importantly, it is highly recommended that a licensed electrician perform the conversion. Electrical work can be dangerous, and ensuring compliance with the NEC and local electrical codes requires expertise and experience. A licensed electrician will have the knowledge and skills necessary to perform the conversion safely and correctly. Now let's delve deeper into the technical aspects of each NEC section. Section 250.140 aims to provide a safe and effective grounding path for older 3-wire range circuits when they are connected to newer 4-wire appliances. The key here is the separately grounded neutral conductor. In a 3-wire system, the neutral conductor served as both the neutral current carrying conductor and the equipment grounding conductor. This could create the potential safety hazard if the neutral conductor became compromised. In a 4-wire system, the neutral conductor is dedicated solely to carrying neutral current, while a separate equipment grounding conductor provides a dedicated path for fault current. This separation enhances safety by reducing the risk of electric shock. Section 250.140 emphasizes the importance of using a proper grounding conductor, either insulated or bare copper. The reference to section 250.122b is crucial because it dictates the sizing requirements for the equipment grounding conductor. The size of the grounding conductor must be adequate to safely carry any fault current back to the source. Section 250.140b simply clarifies that the grounding conductor must terminate at the grounding terminal in the range receptacle. This ensures a direct connection between the appliance's grounding system and the building's grounding system. Section 250.140c addresses a specific scenario where a grounding terminal is present on the range receptacle. In this case, an additional equipment grounding conductor is required to connect the receptacle's grounding terminal to a grounding terminal in a separate outlet box. This creates a redundant grounding path, further enhancing safety. This additional conductor must be the same size as the branch circuit conductors. Section 250.142 focuses on grounding and bonding requirements that apply to ranges and cooking appliances regardless of whether they are connected to a 3-wire or 4-wire circuit. The primary goal is to ensure that the appliance's metal parts are properly bonded to the grounding system, minimizing the risk of electric shock. Section 250.142 requires a grounding and bonding jumper between the range's frame and the equipment grounding conductor. The size of this jumper is determined by Section 250.120b, which bases the size on the size of the ungrounded conductors. The purpose of this jumper is to provide a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Section 250.142b clarifies that the equipment grounding conductor of the branch circuit must be connected to the grounding terminal of the appliance. This applies to ranges, wall ovens, countertop ovens, cooktops, and even range hoods. This ensures that all metal parts of the appliance are properly grounded. Section 250.142c addresses situations where the manufacturer's instructions specify how to connect grounding conductors to the range receptacle. In these cases, it is essential to follow the manufacturer's instructions precisely. They may have specific requirements for grounding that go beyond the general NEC requirements. Let's consider a practical example to illustrate these concepts. Imagine an older apartment complex wired with 3-wire range circuits. A new tenant wants to install a new electric range that requires a 4-wire connection. Firstly, it's essential to verify that the apartment's electrical service has a separate grounding conductor. This may require consulting with a qualified electrician or reviewing the building's electrical plans. If a separate grounding conductor is present, the next step is to install a 4-wire receptacle that is properly grounded. This involves running a new equipment grounding conductor from the receptacle back to the electrical panel, connecting it to the grounding bus. At the range, the grounding conductor from the receptacle is connected to the grounding terminal on the range. A grounding and bonding jumper is also installed between the range's frame and the grounding terminal. The neutral conductor from the receptacle is connected to the neutral terminal on the range. It is extremely important to disconnect the original neutral to frame bonding jumper within the range. This jumper is only appropriate for 3-wire connections and must be removed for a 4-wire installation. Failure to remove this jumper can create a dangerous situation where the range's metal parts are energized under certain fault conditions. If the apartment complex does not have a separate grounding conductor, it may be necessary to upgrade the electrical service to provide one. This can be a significant undertaking, potentially involving replacing the service panel and running new wiring. In this case, it is absolutely essential to consult with a licensed electrician to ensure that the work is done safely and in compliance with all applicable codes. When selecting the size of the equipment grounding conductor, it's important to refer to Section 250.122b in the NEC. This section provides a table that correlates the size of the ungrounded conductors to the required size of the equipment grounding conductor. For example, if the branch circuit conductors are number 8 American wire gauge copper, the equipment grounding conductor must be at least number 10 American wire gauge copper. Similarly, the grounding and bonding jumper required by Section 250.142 must be sized according to Section 250.120b. This section also provides a table that correlates the size of the ungrounded conductors to the required size of the grounding and bonding jumper. It is also important to consider the ampacity of the branch circuit conductors when selecting the appropriate wire size. The conductors must be sized to safely carry the expected load of the range. The NEC provides tables that specify the ampacity of different wire sizes based on their insulation type and installation method. It is essential to use the correct wire size to prevent overheating and potential fire hazards. In addition to the NEC requirements, it's also important to be aware of any local electrical codes or regulations that may apply. Local codes may have additional requirements or restrictions that must be followed. Always check with a local electrical inspector or building department to ensure compliance with all applicable codes. Finally, it's worth reiterating the importance of hiring a licensed electrician to perform this type of work. Electrical work can be dangerous and mistakes can have serious consequences. A licensed electrician has the training, experience, and knowledge necessary to perform the conversion safely and correctly. They will also be familiar with the NEC and local electrical codes, ensuring that the installation meets all applicable requirements. To summarize, converting a 3-wire range circuit to a 4-wire configuration requires careful attention to detail and a thorough understanding of the NEC. Sections 250.140 and 250.142 provide specific requirements for grounding and bonding of ranges and cooking appliances. It's essential to verify that the electrical service has a separate grounding conductor, select the correct wire sizes, and follow the manufacturer's instructions. And most importantly, always hire a licensed electrician to perform the work to ensure safety and compliance with all applicable codes. Remember, safety always comes first.